the beginning? The problem? Go for it, Liz. So first off, when we look at our equations, h is always going to be the height of the object, right? So when we look at our height, that's how high it went. That's kind of like our y, right? So h and y are kind of like the same thing when you think of the general form of the quadratic. T is your time. That's over here when we're looking at our time down here. That is very much the same as in our general form of the quadratic. That's like your x, right? So y is like the h, x is like t. C is the initial height in feet which the object was dropped from or launched. So in this case, it would be 4 because this is at time 0. This is where it started, okay? V is going to be our initial velocity, usually in feet per second, that when an object is launched. If V is less than 0, that means it's going downward. That makes sense, right? Because that's our lead coefficient, right? That's telling us our parabola has to be going down. If V equals 0, that means it was dropped and it has no initial velocity, right? And if V is greater than 0, it's going to be propelled upwards. Most of ours, because of gravity, are going to be negative. So on that next page in your notes, as you're looking down, we want to take a look, and it says, Kate, you want to read that? An object?
Okay. An object is launched directly upward at 64 feet per second from a platform 80 feet high. What will be the object's maximum height? Where will it attain this height?
So we want to start off, we want to write our equation. So because of velocity, gravity is going to be negative 16 t squared. Because our object is launched and we know it's going upward at 64 feet per second, that is going to be our velocity, 64 t. And it started from a height of 80 feet. So when I'm looking at this picture, I know this is 80, right? That's 80 feet. That's my height. This is our time. We're trying to find when the time equals 0, okay? When it hits the ground. But this question says, going back to our original one, haven't we been doing these since the first lesson of this unit? So this isn't using the quadratic formula, right? You're going to find negative b over 2a to get our t coordinate. So in our case, t is going to be equal to, I'm going to put negative b, which is negative 64, divided by 2 times negative 16. So on your calculator, although some of you might not need to, negative 64 divided by negative 32 on gives us 2 seconds. Okay, you might not have needed your calculator for that one. So we have the x coordinate, right? That is not our, this is just our time. We now need to find h, our height. So you are going to plug in 2. It's going to be negative 16 on your calculator times 2 squared, plus 64 times 2, plus 80. 2 seconds, our height will be this point, 2 seconds, and 144 feet. So if we're interpreting our solution, we just have the 2 and the 144, and what you're going to see in this interpreting part is that they are telling us equation for maximum vertex, the highest point to the vertex is 2, 144. The 2 stands for 2 seconds. So just making sure you label your answers. So in summary, our object will reach its maximum height of 144 at exactly 2 seconds. So just making sure that you have labels with yours, that when we think about our ordered pair, the 2 and the 144, keeping the labels with those so that we know it reaches maximum height 2 seconds after it was launched. So that's what you've been doing before. Now, Now, top of the next page, we're going to talk about when it hits the ground. Okay? Different problem, we're setting up a different situation on the top of that next page. So, as you are looking at that one, anyone want to volunteer and read our situation for us?
A ball was thrown from the top of a 128-foot tall building with an intentional velocity of 32 feet per second. How long will it take for the ball to hit the ground?
So we want to know our time, right? We don't want to know the vertex. We don't want to know how high up it went off that building. We just want to know from when it was launched to when it hit its ground, how much time. So the question is asking for the location of height 0. So if you wanted to think about this, we're really thinking about replacing this height with 0. We're trying to say when is it equal to 0, which is the quadratic formula, and we want to solve it. So finding that x-intercept, we're going to use, in this case, it's a solved equation using any method. Before you start plugging in your quadratic equation, I want you to think about this problem. If we start off with 0 equals, does anyone see a greatest common factor in this that would make it much easier to get rid of? 16, and we're going to actually factor out negative 16. What are we left with when we factor out negative 16? Positive t squared minus 2t minus 8. Now, I have some of you that would go, oh, I just want to use that quadratic formula, it makes so much sense. But here's the thing, this equation, the numbers are pretty nice. This is really easy to factor. Because at this point, what multiplies to t squared is going to be t and t, right? So in my parenthesis, I'm going to have a t. And in the other parenthesis, I'm going to have a t. And it has to multiply to negative 8. And so I keep this negative 16 out in front, and it had to be equal to negative, has to be equal to 0. I'm going to have 4 and 2, right? The negative 4, positive 2. My two solutions, can negative 16 ever equal 0? No. So now I'm going back to our lesson t minus 4 equals 0, which means time of 4 seconds in this case, or t plus 2 equals 0, and I get time of negative 2, which doesn't make sense. Time can't be negative, right? If we are looking at that. So if we are looking at this solution, the question says, when will it hit? This is our solving. This is the work we want to do. Once we have solved, we want to interpret that solution. And our interpretation of that solution is the equation has two x-intercepts, but our key thing is negative 2 and 4. The negative 2 doesn't fit our domain. So when we think about that, negative 2 does not work as our domain. So our solution is it will reach the ground after 4 seconds from being thrown or launched, however you'd like to think about that. Negative 16 t squared plus 48t plus 288. I have to get it equal to 0 first. So we've got to subtract 320. So 288 minus 320. And I'm going to put my equals 0 now behind the equation instead of out in front. I'm going to have negative 16t squared plus 48t gives us, what you get, most of you I saw put it in your calculator, a negative, how much? 32. 288 minus 320. Oh, again, I can factor out greatest common factor of negative 16. Do that. T squared. We are going to have minus 3t plus 2 back parenthesis equals 0. We want to look at factors that multiply to 2, and our only options to multiply to 2 are 2 and 1, and they're both going to have to be negative, and negative times negative does give us positive 2, and then I'm going to have t. So this goes back to kind of applying everything that we've been doing in this unit, not always just using that quadratic formula. So we have t minus 2 equals 0, and we're going to have t minus 1 equals 0. So when are our times? Our two solutions are going to be 2 and 1, which if we look at our situation, this means this was our 1 at 320, and this is our 2 at 320, right? We didn't have to find the vertex, but where do you think that vertex is at how many seconds? 1.5, right? It has to be halfway in between. Those have to be symmetric. So now we just want to interpret our problem, and again, I'm going to show you what we had written there. So as you are looking at that, and again, you don't have to have everything word for word here, but our two answers, those two ordered pairs that we wrote on our graph, 1 320 and 2 320, and it means that the rocket height of 320 feet is at 1 and 2 seconds. So, did we answer the question? The question said, how long will the rocket be above the ground? So here's the most common mistake that I'll have people put down. They'll put, our two answers are 1 second and 2 seconds. But the question says, how long was it above here? So you have to subtract 2 minus 1, and that's why this. The rocket will be at least 320 or above for 1 second. Okay? We're looking at how much time to stay above that level. Okay? Last part. 2 more questions left in your notes that we need to look at. This one says, an object is catapulted from the top of an 80-foot building. The initial velocity is 32 feet. What is the highest point it reaches? What are we trying to find there? Vertex. Which part of the vertex? X or Y? This is the Y vertex. How long does it take to reach the highest point? We're also trying to find the vertex, but this time the what? The X, okay? And how long does it take it to be at least 80 feet above the ground? This is where we are setting it equal to 80 feet, right? We want our equation equal to 80 feet. So what is our equation going to be? We need to start off with the height equals. Because it's being launched and because of our pull of gravity, we're going to have negative 16t squared. Plus, what is our t going to be? What was our velocity? 32. And it was launched from what height? Launched from 80. Top of an 80-foot building. How long will it be above that 80-foot, be above that around the ground? So we're going to start with our vertex, right? To find the vertex, t is equal to, this is where you write. Some of you miss this formula. So I would strongly recommend maybe writing the formula when you start it, even if you, I don't always get this right and plug it in my calculator. Also, I'm going to be checking for work on the test when you do this, so having this down is going to at least give me, oh, you got to have an idea. So our vertex is going to be at negative 32 divided by negative 32, which is time of 1. Okay? So how long did it take to reach its maximum? We would want to answer the question with 1 second. Right? What is that height? So now to find the actual height, I'm going to take h equals negative 16 times 1 squared plus 32 times 1, or 32 plus 80. So when you put it in your calculator, do you really need to put the 1 squared and the 1 in there? No, probably just negative 16 plus 32 plus 80, which is going to give us our height of 96. So what is that maximum height? It's 96 feet. And next we are taking a look when it will be above, at least 80 feet or above. So we know, if we think about this, it was launched from the top of this, right? And we want to find, if it started at 80, we're just trying to find this other time over here, right? We've just found that this was at 1 second. And 96. Now, some people might be looking at it and going, oh, if I know the vertex, and this is 80 and this is 80, do I have to go through the work of setting up the equation? Some of you might not recognize that. So I'm just going to show you, and then we will come back to that, what I'm talking about here. Okay? But How would you solve it if it wasn't as nice? This one is pretty nice because it gives us 80 and we started at 80. So we would put 80 equals, that's our height, negative 16t squared plus 32t plus 80. And when you set it equal to 0, you're going to have negative 16t squared plus 32t. Because this is going to cancel, right, by subtracting 80. And this was probably the question on the quiz that more people got wrong when I asked you to solve a problem like this. And I said, solve this any method. And you told me one answer. You're like, what do you mean I can't factor it? So if I'm looking at this, I can still factor greatest common factor, right? Just like we've been doing. Greatest common factor is still going to be negative 16. But they also both have a t in common. So I'm putting negative 16t. That leaves me with t minus 2, and that's equal to 0. And so a lot of you got, when we solved just this equation, you were able to tell me 2. But this other time is when negative 16t equals 0, and that is time 0. Which makes sense. That's where we're starting from, right? So if it's been in the air 2 seconds to get to here, the answer to the question is when you knew the vertex, how long was it above the ground? And in this case, we should have had our answer be 2 seconds above the ground, at least 80 feet or above. Okay? So maximum height was 96 feet. We wrote that up by the question. Time was 1 second for our vertex. And C, if we were looking at that, it's higher than 80 feet for 2 seconds. So, taking a look at the next one. Ready? Okay. So this time a rocket's launched. I give you the equation. Does it make sense if you would have had to write the equation yourself? Okay. This is our initial height. This was our velocity, right? And this is the pull of gravity. And it says when will it hit the ground? Which means we want to set it equal to h equaling 0. So if h equals 0, and if you like the 0 behind, you can start with your negative 16t squared plus 92t plus 24 equals 0. This time the greatest common factor is not negative 16, but it is what? How about 4? So because it's easier to factor when t squared is positive, we're always going to factor out, in this case, a negative 4. Okay? Because it is much easier to factor if I have t squared. But it's not just going to be t squared. It's going to be how many t squared? 4t squared. 92 divided by 4 gives us a 23. And we should have negative, right? 23. And then our last one is going to be minus t. We have the t and minus 6. Now some of you like factoring with that AC method, and others of you that just gave you like, oh my gosh, I have no clue how to do this. So could you use a quadratic formula? Definitely. Okay. You could factor this in that you could think of this is going to be 4t squared, and you're going to split this with your 2t terms minus 6 equals 0, and then you'll do the factors. What would I have been looking for some of you, you don't like taking the time for the AC, but the AC would have been 4 times negative 6. That's negative 24, which means it has to multiply to negative 24 and add to negative 23. I'd go with negative 24 and 1, right? Because that adds to negative 23. To me, this is easier, but some of you will prefer to not do it this way. You will just plug it into the quadratic formula. If you did use the quadratic formula, so if you're doing it this way, I'd like you to try to finish solving it if you want to solve it by factoring. If you didn't and you wanted to use your quadratic formula, again, you would be going, this is the simpler equation to use for your quadratic, right? So we would have negative b plus or minus so that's using the quadratic. The other way is factoring. if we were factoring this, someone did the factoring way, Kylie, would you have? So we had one factor being 4t plus 1, because when we were looking at this last one was a plus 1 times that t, so 4t plus 1. And t minus 6. And that was equal to 0. And you did have this negative 4 out in front here, okay? But when you set it equal to 0, that kind of disappears, right? And if 4t plus 1 equals, if we are looking at that, here t is going to be equal to a negative 1/4, and here t equals times 6. So this one, because of our domain, shooting it off the building, right? We can't have time being negative. So when we look at our solution is going to be that it should have hit the ground after 6 seconds. As you were looking at that. Okay. Tonight's homework isn't that long. So some of you, if you didn't finish yesterday's, you want to make sure you're showing it.